The country is currently seeing its worst energy crisis in decades.
Germany took to the streets in response to the energy crisis,
facing its worst ever power crisis.
One question on everyone's mind: can we keep the lights on?
Fusion that you were able to create could have powered the entire power grid of the world, basically.
The nuclear fusion is a reaction that two or more light nuclei combines to form a heavy nucleus. If the reactants are both elements before iron in the periodic table, the mass of the products will be less than the sum of the masses of the reactants. The mass loss is released in the form of energy. In order for this merger to take place, the two positively charged nuclei need to be brought close enough together to enter the range of the strong interaction force. There are two ways to accomplish this, one of which is to get the two nuclei moving fast enough to crush each other, or to get the nuclei pressed close enough to each other, which means high temperatures and pressures are required. Controlled nuclear fusion is the engineering of high temperatures and pressures to force light nuclei to merge into heavy nuclei and to control the smooth output of energy.
This picture shows the tokamak, which is currently the dominant controlled fusion device. In addition to a donut shape with ring magnets, the tokamak device has a columnar electromagnet in the center. By rapidly changing the amount of current and passes through the electromagnet, a rapidly changing magnetic field can be generated, thus triggering an induced current in the plasma to form an induced magnetic field that surrounds the plasma. This magnetic field is superimposed on the original magnetic field in the donor to form a twisted magnetic field, which neutralizes the outward force of the particles and allows the particles to reach a dynamic equilibrium in the up-down, left-right, and reciprocating motions. The outermost ring of the tokamak also has several large ring electromagnets to control the size and the shape of the plasma. This configuration later proved to be very reliable, and the comprehensive index of the plasma of the tokamak T3, built by the Union of Soviet Socialist Republics in the 1960s, exceeded that of the United States by an order of magnitude at the same time, and this was the feasibility and high efficiency of the tokamak device that was recognized by the international community from T3 onwards.
If we can succeed in controllable nuclear fusion experiments, we're going to approach a new era just like solar panels did in 1950s. However, it will be around 2030 before the cost of PV plus storage average out to the same level per kilowatt hour as thermal power. That's when PV can really make a difference. In contrast, nuclear fusion has a much faster rate of development. Nuclear fusion, which has the potential for much higher energy density than PV, can facilitate all industries even in space exploration.
In California, we succeed to get 2.5 megajoule of energy from 2.1.
The future of the nuclear fusion is infinite, but we are not even close to that now.
Plus, Jason Party and Anthony Ball mentioned in their book that the next 100 years or so, human are going to have an energy revolution.
There has to be someone like create something new or find something new, and to improve the whole like structure of the tokamak or somewhat. And yeah, so it depends on how people allocate this useful source to everyone else, or just blocking all the other countries for their own benefit. So as long as the technology is not open for the whole public, then there will be a problem for the development of the whole human being, and it can be a very great milestone for the human development in this history. But it also can be the final disaster of the whole human being. Yeah, it can cause extinction.
But it could also be a start. the beginning of the universe.